National Electrical Code Article 314 concerns outlet, device, pull, and junction boxes, conduit bodies, fittings, and handle enclosures. Section 314.16 covers the number of conductors permitted in a box. Specifically, 314.16 addresses conductor fill for boxes. However, the provided answer references the allowance of running non-metallic sheathed cables, also known as type NM cable, through metal studs. The relevant information regarding the number of cables permitted through metal studs is found elsewhere. Considering the rule of only running 2 cables, and 3 at the absolute max, we can infer that we are discussing running NM cables through the pre-punched holes in metal studs. This is the most typical way to run NM cable in metal stud construction. According to the National Electrical Code, not more than 2 NM cables are permitted in any stud space. 3 NM cables are permitted where one cable is a continuous unspliced feeder supplying power to the other 2 cables. It is important to note that this requirement specifically applies to metal studs. When running electrical cables through metal studs, it is crucial to adhere to the National Electrical Code guidelines. The NEC aims to ensure electrical safety and prevent hazards associated with overheating or insulation damage. Overcrowding cables in a stud space can lead to heat buildup, potentially causing insulation breakdown and increasing the risk of electrical fires. The 2-cable limit in a stud space provides adequate space for heat dissipation and minimizes the risk of damage. The exception allowing 3 cables when one is a continuous feeder recognizes a specific wiring scenario. A feeder cable supplies power to other circuits. In this case, the continuous feeder passes through the stud space without being spliced or terminated, while the other 2 cables branch off to supply power to local devices. This arrangement is permitted because the feeder cable's heat generation is distributed along its length, reducing the concentration of heat within the stud space. Adhering to the 2-cable limit is a best practice for cable management. Even though the NEC permits 3 cables under certain conditions, limiting the number to 2 provides an extra margin of safety. This practice also simplifies future wiring modifications or additions. When only 2 cables occupy a stud space, there is more room for maneuverability and less risk of accidentally damaging existing wires during alterations. Before running any electrical cables, it is essential to inspect the metal studs for any sharp edges or burrs. Metal studs often have pre-punched holes for cable routing, but these holes may have sharp edges that can damage cable insulation. Using a file or deburring tool to smooth the edges of the holes prevents insulation damage and reduces the risk of electrical shorts. When running cables through metal studs, it is important to support the cables properly. The NEC requires cables to be supported at intervals not exceeding 4.5 feet and within 12 inches of boxes, cabinets, and fittings. Cable supports prevent the cables from sagging or straining, reducing the risk of insulation damage and maintaining a neat and organized wiring system. Various types of cable supports are available, including cable ties, straps, and staples. Choose the appropriate support based on the cable type, stud spacing, and installation requirements. When running multiple cables through the same hole in a metal stud, ensure the hole is large enough to accommodate all the cables without overcrowding. Overcrowding can cause insulation damage and hinder heat dissipation. If necessary, use a larger hole or drill a new hole to provide adequate space for the cables. Avoid running cables through the stud space where they may be exposed to physical damage. Protect cables by routing them away from sharp objects, moving parts, or areas where they could be accidentally snagged or cut. If cables must be run in exposed locations, use appropriate protection methods such as conduit or cable trays. When installing electrical boxes in metal stud walls, ensure the boxes are securely mounted to the studs. Use appropriate fasteners such as screws or rivets to attach the boxes to the studs. Properly mounted boxes provide a stable and secure enclosure for electrical connections and prevent the boxes from moving or vibrating, which could damage the wiring. When making electrical connections in boxes mounted in metal stud walls, ensure the connections are properly tightened and insulated. Loose connections can cause arcing, overheating, and electrical fires. Use appropriate wire connectors, such as wire nuts or terminal blocks, to make secure and reliable connections. Wrap the connections with electrical tape to provide additional insulation and protection. After completing the wiring installation, inspect the work to ensure it meets all applicable code requirements. Check for proper cable support, secure box mounting, tight connections, and insulation integrity. Correct any deficiencies before energizing the circuit. Document the wiring installation, including cable routes, box locations, and circuit assignments. Accurate documentation facilitates future maintenance, troubleshooting, and modifications. Keep the documentation readily available for reference. Remember that the National Electrical Code is a comprehensive set of rules and regulations governing electrical installations. It is essential to consult the latest edition of the NEC and any applicable local codes before undertaking any electrical work. Always follow the code requirements to ensure electrical safety and prevent hazards. If you are unsure about any aspect of electrical installation, consult a qualified electrician. They can provide expert guidance and ensure the work is done safely and in accordance with code. Electrical work can be dangerous, and it is always best to err on the side of caution. By following the NEC guidelines and best practices, you can ensure a safe and reliable electrical system in your metal stud construction project. Always prioritize safety and consult with qualified professionals when needed. Improper electrical work can lead to serious consequences, including electrical shock, fire, and property damage. Take the necessary precautions and follow the established standards to protect yourself and others.